CDN, Content Delivery Network, is a distributed network system primarily designed to accelerate the delivery of static content, reduce server load, and improve user access speed and experience. By replicating content across multiple geographically distributed server nodes, CDN enables users to retrieve content from the node closest to them, thus enhancing access speed and reducing latency. The core principle of a CDN is to cache content across multiple globally distributed servers, called edge servers. When a user requests a resource, the CDN automatically delivers it from the server closest to the user instead of fetching it directly from the origin server. The detailed process is as follows. 1. User request. When a user accesses a website or application, it first sends a request for resources to the DNS server. 2. CDN routing. The DNS server, based on the user's geographic location, routes the request to the nearest CDN edge server. 3. Cache lookup. The CDN edge server checks if it has the requested content in its cache. On cache hit, if the content is cached, the CDN directly returns the cached content, providing a fast response for the user. On cache miss, if the content is not cached, the edge server requests the resource from the origin server, then caches it for future requests. 4. Content delivery. The user receives the content from the cache rather than the origin server, reducing load and latency. Advantages of CDN are: 1. Improved access speed. With CDN nodes distributed across multiple regions worldwide, user requests can retrieve resources from the geographically closest node. This reduces latency and response time, enhancing the user experience. 2. Reduced server load. By distributing content across multiple edge nodes, CDNs decrease direct access to the origin server, dispersing traffic loads and reducing the risk of server downtime. 3. Bandwidth optimization. Through caching and compression, CDNs minimize data transfer volumes, optimizing bandwidth usage and saving costs. 4. Increased availability. Due to the distributed nature of CDNs, even if certain nodes go down, other nodes can still serve content, ensuring high availability and fault tolerance. 5. DDoS protection. CDNs help mitigate DDoS attacks by dispersing traffic loads, protecting the origin server, and enhancing security. Disadvantages of CDN are: 1. Content update delays. Since CDNs rely on caching, if content on the origin server updates, but the cache doesn't refresh promptly, users may receive outdated content. 2. Complex cache configuration. For dynamic or frequently updated content, configuring CDN cache strategies effectively can be complex and may lead to cache invalidation issues. 3. Cost. While CDNs optimize bandwidth and reduce server load, they may add extra expenses, especially for smaller websites or applications. 4. Geographic dependency. If CDN edge nodes are sparse in certain regions, user experience in those areas may not improve significantly. Some CDN examples are: 1. Video streaming sites. Platforms like YouTube and Netflix rely on CDNs to distribute video content quickly, ensuring smooth streaming experiences for users worldwide. 2. E-commerce. Platforms such as Amazon and Alibaba use CDNs to improve page loading speeds, allowing users to browse products and place orders efficiently. 3. Social media. Social media platforms like Facebook and Instagram utilize CDNs to deliver large volumes of static resources, such as images and videos, ensuring seamless access for users globally. 4. Game distribution. Gaming platforms like Steam and Epic Games use CDNs to distribute large game installation files, boosting download speeds and reducing server load. Thanks for watching. For more information, please visit bowsier.com.